Hello all, welcome to the subject of VLSI Design and Technology. I am Professor Meenakshi Panta from Electronics and Telecommunication Department, Parvatibai, Gyanba, Mojay College of Engineering, Waguli, India. So today in this lecture, we are going to study about supply and ground bounces. Supply and ground bounces. The output voltage of an IC is with respect to ground of the chip. Hence, in a system, the tiny wire connection between the chip and the lead frame of the package contributes a small amount of inductance in a circuit. When V out goes low, a spike of current flow through this inductance and creates a voltage spikes. A device connected to the ground of the circuit indicates a logical zero. This is called as a ground bounce. Then the VDD and the ground pins of the package are not at VDD and the ground. VDD and ground are established and regulated at the power supply. Therefore, both the resistive component and the inductive component between the package pin and the power supply ground are exist. Therefore, the designer used heavy copper plane that makes them as full as possible with the few cuts and holes as possible. But in fact, this inductance in a mini high-speed circuits is just too large to tolerate. So the bypass capacitors are used in a VLSI integrated circuit. The purpose of bypass capacitor is to implement the looks like a regulated VDD and ground right at the package for a short time until the inductance of the plane is overcome. The transient current when the logical device changes state will not have to flow to the end from the power supply. They simply follow and from the capacitor. This is about supply and ground bounces. Let's see some power distribution techniques. Power distributed tech. The power distribution has two problems that are sizing wires and power distribution network. Here in the figure shown in a slide is a branch that carries the current in all the branches. If the logic gates use few standard transistor size, Computing the power in a line in is challenging. So, in order to design a large integrated circuit, simple rules are chosen for the power supply width. Hence, the metal variegation is the problem in a power supply distribution. Here, one thing will become like decoupling capacitor. In order to reduce the power supply noise and capacitor across the power supply pin are used in a printed circuit board design. Further, in the large size integrated circuits, decoupling capacitors are used in the semiconductor chips. Therefore, in a microprocessor, integrated circuits to add decoupling capacitance. A separate chip is mounted on the top of the integrated circuit. Next point is power optimization. Power optimization. We know how to optimize the power consumption of an isolated logic gate when designing logic networks. One way to reduce the power consumption is to capacitance driven by the gate. However, since the gate consumes almost no power when consistent, the most effective way to reduce its power consumption is to make it challenge its output as few times possible. If there is no change in the output value, the gate is not required. The logic gate circuit to reduce the number of the uncertainty changes to gate output are designed. The illuminated, the glitching, the method of the power reduction can be used. Glitch reduction way be used in the subsequential systems to stop the propagation of the glitches. Sequential machines are incorporated with the registers. Here I will show one figure of flip-flop stop glitch propagation. In sequential timing optimizations is considered as retiming shown in a figure. The flip-flop used to reduce the power consumption. A flip-flop is connected after the logic with the high signal transmitted propagation. The propagating and the timing extra level of the registers are added. Scheduling the register was important when there are more glitches processing segment are present. However, the number of the cycle required to compute the machine outputs should be compatibility or compatible. Let's see interconnect routing technique. Interconnection, interconnect routing techniques. Up till this we discussed about flow of the system on a chip. Now we will study the chip level layout and the circuit design. The basic objective of the design are more are area, delay and the power. Flow planning is called as the chip level layout design. The floor planning is divided in three phases that are black placement, global routing, delayed mounting. In addition, for the planning is divided in a three phase. First one is block placement, global routing, and detailed placement. The floor planning are block placement, in addition to this, the layout design is divided into placement and routing. In a global routing, the first port line